percent composition of a compound in chemistry can be thought of in two different ways. Numerically, as in number of atoms, or by mass, the mass of a particular element compared to the mass of the total compound. For example, water. I could think of the percent composition numerically as in there are 3 total molecules. There are 2 hydrogen molecules and 1 oxygen molecule, in which case 66% of this compound would be hydrogen and only 33% would be oxygen. But normally in chemistry, I'm going to be interested in the percent composition by mass, which is something entirely different. Because the mass of a hydrogen molecule is minuscule compared to the mass of an oxygen molecule. So while there are more hydrogen molecules, their mass is so little in comparison to oxygen that the percent composition by mass is going to be strongly in favor of the oxygen. So to find the percent composition of mass, I'm going to take the mass of the element and divide it by the mass of the compound. Just like any other percent of anything, like on a test, I take the number of answers I got correct and divide it by the total number of answers. For the mass, percent composition of mass, I take the mass of a particular element and divide it by the total mass of the compound. For example, water has a molar mass of 18.01 grams per mole. And this is how I'm going to go about finding the percent composition. I'm going to use the molar mass, because I can easily find out the molar mass of any compound by using the periodic table, and then I can also look up that element very easily and find out the individual element's molar masses. So it's a very easy and convenient way of finding percent compositions. To find the percent composition of hydrogen, I need to find the total amount of grams in every mole of this compound, in which case there are 2. So I'd say, what is the molar mass, which is 1.01 grams per mole, and there are 2 of them, times 2, which is going to give me 2.02 grams per mole. Now to find the percent composition of hydrogen in this compound of water, I take the mass of the hydrogen and divide it by the mass of the total compound, 18.01 grams per mole. The units are going to cancel, and then I'm going to get, I already calculated this out beforehand, is 11.22%. So the total compound has a mass of 18.01 grams. So this is if I had 1 mole. If I had 1 mole, it would have a mass of 18.0 grams, and 2.02 of those grams would be hydrogen. So I don't forget, 11.22% hydrogen. Now I need to find the percent composition of oxygen. I look up the molar mass of oxygen. It is 15.99 grams a mole. There is only 1, so that's very convenient. I don't have to do any multiplication. I just do 15.99 grams per mole, divide it by the mass of the compound, 18.01 grams per mole, and this gives me a total 88.78%. So even though there is only 1 oxygen atom and 2 hydrogen atoms, because each hydrogen atom only has a mass of 1.01, it has a significantly less total mass in this compound because it weighs so much, or not really weighs, it has so much less mass than oxygen. So even though there are two, oxygen is 88% of the mass. And for an easy check, both of these should add to 100, or 99, or 100.001, or something like that. And that is due to rounding, but it should be equal to 99.99, 100, or the slightest bit over 100. And the only reason it wouldn't equal to 100 is, again, because of rounding. Let me do one more quick example of a larger molecule. This is Ibuprofen, or it goes by the trade name of Advil. And it has a chemical formula of C13H18O2. And it has a molar mass of 206.29 grams per mole. So if I have 1 mole of this ibuprofen, then I have 206.29 grams of mass. And I want to find the percent composition of each of the individual elements, which are carbon, hydrogen, and oxygen. I'll do carbon first. Carbon has a molar mass of 12.01 grams per mole. Sometimes it's helpful to just leave a little note that this is carbon, because sometimes in large molecules there are lots of different elements and it can be easy to lose track of what I'm working on. 12.01 grams, and there are 13, and this is going to be equal to 156.13 grams per mole. Now I want to find the percent composition of carbon now that I know the total grams per mole of carbon in this compound. Now I divide the amount of carbon by the mass of the total substance. Let's do it down here. And the total mass is 206.29 grams per mole. And I've calculated all these out beforehand. And this is equal to 75.68%. Carbon. And this is kind of expected because there's a lot of carbon. Carbon is not as large as oxygen, but it's very close to it on the periodic table. It has a mass of 12.01 grams per mole. Oxygen has 15.99. There are only 2 oxygen atoms in this molecule. And hydrogen, while there are more hydrogens that have such a small mass, it's not going to make much of a dent in the total mass composition unless there are a lot of hydrogens. But most of the time when there is a hydrogen, it's going to be bonded to a carbon or some other element that's more massive. So I can't really think of any compound that nitrogen has more mass than anything, really. So this is 75%, so I'll do hydrogen next. That's probably going to be very low because it's very small. 1.01 grams per mole times 18. This is equal to 18.18 grams per mole. Divide this by the total. and this is equal to 8.81%. Hydrogen. So a very small percentage, even though numerically it is the most common, but as far as mass, it's just too small to be a significant part of the total mass of the molecule. And finally, there are two oxygens, each being 15.99 grams per mole times 2, and this is equal to, oh, I forgot to multiply it out. 15.99 times 2, 31.98 grams per mole. Then I divide this, I'll write it out first. Divided by a total. Grams per mole. This is equal to 15.50% oxygen. And then all three of these together are my final answer.